All right, let's talk about Nvidia's latest monster AI model, Jet-Nemotron. Now, the big claim here is that it's not just smarter than its rivals, but it's unbelievably faster. So what in the world is their secret? Let's get into it. First, just a quick disclaimer. Everything we're about to cover is for informational purposes. We're just breaking down the tech here, not giving out any kind of advice. Okay, so let's start with a really big question. We have all these amazing AI models now, right? They can write code, they can write poetry, they can analyze massive documents. But there's this huge problem nobody loves to talk about. They can be painfully slow and super expensive to run. Why is that? Well, the answer, ironically, is hidden in the very thing that makes them so smart in the first place. It's a mechanism called attention. And it turns out, the feature that gives these models their incredible power is also their biggest, heaviest anchor. And this gets us right to the heart of the matter. What's become a massive challenge in the AI world? The efficiency problem. So this right here is the culprit. It's called full attention. Now, think of it like this. For every single word in a document, the AI compares that word to every other word to figure out the context. It's incredibly powerful, but look at that O of n squared formula. That means if you double the length of a document, you don't just double the processing time, you quadruple it. It hits a computational brick wall fast. So when you're facing that kind of exponential slowdown, how on earth do you break through that wall? Well, Nvidia thinks it has a really, really clever answer. And here it is, Jet-Nemotron. This isn't just another language model. It's a totally new kind of beast. It's a hybrid, which means it very strategically combines that powerful but slow full attention with way faster, more efficient methods. It's all about getting the best of both worlds. And this really sums it all up, right? For years, the trade-off in AI was simple. You could have a model that was really, really smart, but it was going to be slow. Or you could have a fast model, but it just wasn't as good. Jet-Nemotron is designed to completely shatter that trade-off. It's about being smart and fast. No compromise. Okay, so how did they do it? This is where we get into the real magic behind Jet-Nemotron. The answer is this absolutely brilliant design process they developed called PostNAS. Now, this is the key. Instead of spending, millions of dollars and months of time building a brand new AI model from scratch, PostNAS is smarter. It takes an existing, powerful model and treats it like a Formula One engine. You don't build a new car, you just surgically upgrade the most important parts, in this case, the attention mechanism. It is genius, and it saves a ridiculous amount of time and money. And here's the four-step playbook. First, it automatically figures out the exact few spots in the model where that expensive full attention is absolutely necessary, and it leaves it just there. Second, for everything else, it tests out a bunch of different super efficient alternatives to find the fastest one. Third, they actually invented their own even better version called the JetBlock. And finally, and this is classic Nvidia, the entire search is hardware aware. It's optimized from the ground up to run like a rocket on their own GPUs. So yeah, this all sounds amazing in theory. But what about the results? Does it actually work? Well, this is where things get absolutely insane. Let's just start with this number. 47 times. The Jet-Nemotron model has 47 times higher throughput. That's basically its raw output speed than a major competitor. I mean, that's not just an improvement. That is a complete game changer. And it gets even crazier. When you feed it really long documents, the exact kind of thing that makes traditional models just grind to a halt, the speedup is even more massive. We're talking up to 53.6 times faster. But look, speed means nothing if the model gets dumber. And this is the slide that should make your jaw drop. Look at the competitor, Qwen 3, 61 tokens per second. Now look at Jet-Nemotron, over 2,800. And then the killer blow. Look at the accuracy on a really tough benchmark. Jet-Nemotron isn't just faster, it's actually more accurate. That's the holy grail right there. Way faster and smarter. Okay, so the tech is incredible. But let's zoom out. What does this really mean for Nvidia as a company? Why is this such a big strategic deal for them? You have to understand, this isn't just about building one cool model. It's about building a deeper, wider, competitive moat that protects their entire empire. And this lays out the whole strategy. First, hardware-software synergy. They design models that are custom-tuned to run best on their chips. It creates a self-reinforcing loop. Then there's the ecosystem advantage. This PostNAS method lets them innovate faster than anyone else. For their customers, all this efficiency means lower costs, which makes it a no-brainer to stick with Nvidia. And it proves they're leaders in AI design, not just in making the hardware. But maybe the biggest thing? They've basically proven that for speed, the size of the model's short-term memory, the KV cache, matters more than just its total parameter count. They're rewriting the rules of the game. And really, the impact here is bigger than just one model. This new method makes it way cheaper and less risky for everyone to experiment with new AI designs. It's an accelerator for the entire field of AI, and Nvidia is sitting right in the driver's seat. So it all comes down to this. For years, the whole industry has been obsessed with this idea of bigger is better. Just build bigger and bigger models. But something like Jet-Nemotron comes along and just completely challenges that assumption. So it leaves us with this one really fascinating question to think about. Does the future of AI belong to the biggest models or the most efficient ones?